Okay, so in this example, determine the required spacing of phi 10 stirrups at the left end of the beam. Left end, it means this side of the beam. We have shear reinforcement, diameter is 10. Okay, just determine the spacing. So it's like it's asking you to design the spacing, Uh, at the left end of the beam shown in figure, f sub c prime of y. Okay, everything is given. We have the cross section. So what we do, we immediately draw, we are supposed to draw the shear force diagram. Okay, so we have W has been factored as a uniformly distributed load, and it includes the dead load and live load imposed on the beam. Okay. Okay. So after we draw the shear force diagram, this would be the shear force diagram. The maximum shear would be at the support. The critical would be at distance d. So we call this VUS, which means VU at the support due to the applied load. And this is VU at D. And based on this, we decide if the beam would is in need of shear reinforcement or not. Based on this value, okay, based on this value for this example is based on this value, we decide if we need shear reinforcement or not. So what we do, we usually calculate phi VC, and we know what phi VC is about, and we get phi VC is equal to 171 kilonewton. Okay, so if phi VC is 171 and VU at D or VUD, we call it VUD, is 274. What does it mean? It means that VU at D is much greater than phi VC. And when VU at D is much greater than phi VC, it means that we need to design for shear reinforcement. In this example, phi is given, so I mean, the diameter is not a choice anymore. Phi is given, which is 10 millimeter. So we decide on phi 10 because in the question is given that we have to give the spacing for phi 10. Okay. So now we need to design. When we design, we need to identify the location within which we need to have shear reinforcement, including the zone in which ACI code recommend the minimum amount of shear reinforcement. And that would be, the zone would be phi VC over 2. So if we locate phi VC over 2 on the diagram, this would be the zone, you could say from here, this would be the zone in which stirrups are needed. Okay, stirrups are needed. We need stirrups within this zone. Okay, we need stirrups within this zone. Beyond this zone, we may not need stirrups unless when we unless when we get the spacing or the number of shear reinforcement, then if like 5.1 as we have explained before, then you need to add one stirrups beyond the zone, okay, but it shouldn't go beyond it shouldn't go beyond half of the beam. It shouldn't beyond this point, the point at which the shear reinforcement, sorry, the point at which the shear force is equal to 0. So this is the zone within which, okay, we need shear reinforcement, and we reinforce it up to this point. In case if you've got the number of stirrups is equal to 5, then that would mean exactly you're gonna get the last stirrups located at this location, okay? When number of stirrups, when we say n, which is equal to the distance okay, the distance that is in need of shear reinforcement, up to over the, what do you call, over what, over spacing, right? Over spacing. So the distance over spacing would give us the number of shear reinforcement. If coincidentally you've got n is equal to, for example, you've got n is equal to exactly like say 7, okay, so 7 stirrups you're gonna need, okay. Of course, that when I say 7 stirrups, we have already placed 1 stirrups from the face of the column, okay. So the zone would be, the distance that I'm claiming is from here up to which point? Here, okay, up to here. So this is the zone where I need to place my stir reinforcement. Okay, this would be the zone where I need to place my stir. So if this distance was equal to, if this distance was equal to, if this distance over the spacing that I have calculated, and I've got exactly 7 or 5 or whatever, so that means the last reinforcement for I mean the last web reinforcement or shear reinforcement would be located at this location. Okay, if it is 5.1, for example, or 7.1, okay, so that means the shear reinforcement is a little bit here. It's close to where the zone is, but it's a bit behind it, okay, a bit. But if like you say 5, if 5 point, yeah, 5.1 would be close to it, but if 7.9, for example, you get 7.9 or 7.8 or 7.7 up to 7.6, so that means the last one would be a bit far away from the zone, from the end of the zone. Okay, so in that case you will need to add, in which case we will cross the zone. In this case, when 7.1, when the number is equal to 7.1, then surely you will cross it by a distance. You will cross the zone by a distance. So you have to make sure that it hasn't crossed the point at which the shear force is equal to 0, because we don't want to go to the other side of the beam. We don't want to go to the other side of the beam. All the time we maintain the shear reinforcement within one side. If the other side is identical, of course, we are talking about identical shear forces on both sides, because the other side, even though this side is in the positive, I mean shear force is positive, the shear force would be negative on the other side. Okay, so that means we will get the same number of shear reinforcement on the other side. So we don't cross the point or the place where the shear reinforcement would be identical on the other side. Okay, so if we know how to get the spacing, so we check now how the problem has been solved. We check that. So this is the zone within which we need to reinforce with shear reinforcement. Okay, this is the zone within which, so we determine the spacing. We need to determine the spacing, and the spacing is based on few things. We need to check few things prior to finding the spacing. Once we've got VU at D or VUD, okay, once you've got this, you check it with what? Once you've got this and you see that you need shear reinforcement, you check it. It should not exceed, we said it shouldn't exceed what? It shouldn't exceed 4 times VC. If it hasn't exceeded this limit, so that means the section, there would be no section modification, right? And you can proceed to provide shear reinforcement. So this is the limit. This is the limit. It shouldn't exceed. So that means VU at D, if it is equal to, if VU at D is equal to, for example, 4 VC. Do we need to modify the shape? If VU at D is equal to 4 5 VC. Do we need to modify the shape, or it's okay to proceed and provide shear reinforcement? If VU at D was equal to 4 VC. We said in the code it has limit. It should not exceed 4 or 5 VC. But if we've got VU at D is equal to 4 times VC, do we need to change to modify the beam cross section or not? Hanya,
بله أستاذ.
my question is تيجي إلى ترسيع كم يعني؟
ناخر أستاذ.
Go. Go change. Bahra.
بله.
چیه والله پرسیار رقم
اگه دوباره به تو بسیار
با دو سه جار بتونم
ئوستازی ئەو بابەتانم نەخوێندەوە ئیتر زۆر باشی نازانم داوای بود نەکەم.
دیدار 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 اوکی everyone
بله
چیه والله پرسیار رقم
بس پێما بێ پێویست ناکە سێکشنەکە بگۆڕین
واي زۆر چاک فمعناه ئەوەیە when VU at D is equal to 4 times VC we don't need to modify because the code is limiting up to 4 VC. So that would be the maximum allowable shear reinforcement, shear force the steel could take. Okay, this would be the maximum shear reinforcement. Shear force the steel could take. Okay. So now we move on, and then what we do, we بله
مامۆستا ئەمە پێشتر دەمانگوت VU at S یعنی لە سەپۆرت بی دەبی یعنی نابی گەورەتر بی لە 4 VC 4 VC یعنی نەک لە D پێشتر لۆ باس کردین گوت لە سەپۆرت یعنی VS نابی گەورەتر
critical location. We said the critical location. We never talked about VU at support. We said VS. VS, not VU at support. We said VS should not exceed, not VU at support. We should said VS. Yeah, VS is not VU at S. It's not VU at support. It's VS is the force that the stirrups should take. And ACI code put a limit. ACI code put a limit. The limit is for VC. So if VS should not exceed that limit. That's all. Okay.
And مامۆستا VS و دەگە VU at D نابی گەورەتر بی لە 4 VC وەنیە مەبەست ئەو هەیە هەردووچیان VS و at D.
The location, just in terms of location, and let me explain to you. This is just the location. VU at D, okay, you get it, for example, for VC, and then you calculate VS based on that. So if VS is less than 4 VC, it would be okay. If VS is equal to 4 VC, my question just now was, the VU, the shear reinforcement, the shear force that the stirrups should take, we have a limit. which is for VC. For VC is the maximum that stirrups should take. If VS is not as support, the stirrups should take that much. So the maximum, if for example, the maximum, if the maximum is, sorry, the maximum is, if I've got like I calculated VS is equal to 4 VC based on VU at, sorry, VU at VUD, okay, VUD, because we have this equation, VU is equal to VS added to VC all multiplied by 5, right? And this VU is the VUD, okay? Is the VUD, is the shear force at the critical location. VC, you have a formula. You calculate VC based on the formula. You've got VC, okay? If now we calculate it based on the VUD that you get it, which is, you have a value like VUD over here is equal to 274. If you've got this 274 and you've got a value for VC, okay, and then you've got 5 VC, you've got 5 VC is exceeding the phi 4 times VC. So that means you need to modify the section. But if VS is equal to 4V times C, okay, a VS, we have eliminated the phi from both sides. So if VS is equal to 4VC, I said, do we need to modify the cross section of the beam? That was my question. Do we need to modify the cross section? Yeah, because we have a limit from the code. It says that the stirrups of the shear reinforcement should not take more than 4 times 5 VC. Okay?
Okay, well.
Okay. So now we calculate, that's right, we calculate VS and then we have to make sure that it has not exceeded the 4 V times C, okay? Has not exceeded. Then we give it an okay. Then we move ahead. Now what we do, we calculate, we call it theoretical spacing. It's based on calculation. This one is based on calculation. We know the formula is AV FYT D over VS, and we know what FYT is the stirrups yield stress for the stirrups, and AV is if we have the stirrups has 2 legs, then we get 2 times for each bar, the area of each bar, which means A sub B, you could say, times 2. The stirrups has 2 legs, and the effective depth, and VS is the amount of shear force that the stirrup would take, which we have checked is okay, no problem with it. So we have all these values, we get the spacing. And based on that, we know that this would be the spacing. This is the final value that we could decide on? No, we have to check furthermore. What do we need to check? We check now we check something else, that if VS, we have some other things, other conditions to satisfy. If VS is either more than 2 VC or less than 2 VC, okay? We have these 2 conditions. So in case if less, we have a set of formula we get out of which we get a spacing, and we choose the least out of all, okay? So that is the condition that we need to look for. And then we see over here, the condition is, yeah, VS is less than, this means that less than 2 times VC, okay? 1/3 of root square F sub C prime times V web D. This whole thing means that the VS is less than 2 times VC, okay? Why? Because VC is equal to, if 2 times 1 VC, 1/6, okay, times root square F sub C prime times B web times D. So you're gonna get the same thing. You're gonna get this one, 1/3, right? 2 with 6, you would get 1/3 times root square F sub C prime B web times D. Okay, that would be So if this condition is satisfied, then you have a set of formula. And as I told you, most of the time, these two values would govern, either this one or the one that we have calculated. So we check that now. We have D over 2, which is 700 over 2, 375, okay? And we choose the least. How much we've got from the previous one? We check 325, and the other one, how much we've got? We've got the same, the same value, okay? Of course, we have applied these equations, okay? All, they are giving all larger values for the spacing, okay? So we decide on the least. So coincidentally, the theoretical one was equal to, was it equal? Is it equal or, no, it's not equal, sorry. The theoretical one is less, so we decide on the theoretical spacing, okay? We decide on the theory, because this has given 375 is greater than 325. I thought it's 325, okay? It's 375 is greater than the theoretical one that we have calculated, so we decide on the 325, which is the least. That would be the spacing for the stirrups. And if we need to now to calculate the number of stirrups, we need to, what we need to do? Number of stirrups. Number of stirrups. What do we do? Is equal to, where is the graph? We go to the graph. Number of stirrups, this is the graph, so number of stirrups is equal to, number of stirrups would be equal to, what? Would be equal to number of stirrups and would be equal to the distance, which is 2.9 over what? Over how much was it? The value, how much was it? 325?
spacing falan.
Okay, 325 converted into meter, so times 10 to the power 3 negative. Okay, so calculate how much would you would get of how much of stirrups do we get? We have to place, I forgot, we have to place one stirrups at a distance equal to S over 2, which is 3, the spacing would be 325 S over, that we have decided on, over 2. So one stirrups is placed. So we have to deduct this space from, I mean, this distance, which is, this should be deducted from this distance. Sorry, we need to deduct this space. Okay. 2.9 minus 325 over 2 and converted into millimeter. So it would be times 10 to the power negative 3. Okay, to be converted into meter. Okay, so how much would be the result for this? How many stirrups do we need for this? For this half of the beam? Qu'est-ce calculate here, Bika?
Ustaz 8.66.
8.6. Okay, now Kebut.
Abdulaziz Ustaz.
Abdulaziz. Now we have 8.6. Okay. For example, if you have calculated it and if it was like 8, so the last stirrups would have been at which location? Aga Hashboya. The last one.
نزيك بقى لسر لا 5 VC لسر ذو لسر.
Exactly here. We could have had it here. But now when it is 8.6, that means the last one. Yep, exactly. The last one would be the eighth one. So if I add now 8 stirrups, I ignore the 6. If I add 8, it would be somewhere here. It's not close. It's not very close because we need 0.6 to get exactly at this location. So do I have a choice of 0.6? No, there is no such choice. So I have to round it up to 9. I have to round it up to 9. When I round it up to 9, then surely it will exceed this zone. It will exceed, so I will have it somewhere here. Okay? I will have it somewhere beyond it. So I need to make sure that it has not exceeded this zone. How do I make sure that it has not exceeded this zone? How do I make sure that it has not exceeded the zone? I say I have 9 stirrups, so that means number of stirrups, n, which is 9, times the spacing. It should not exceed. It should not exceed 4 meter minus this s over 2. This s over 2. Okay. Okay, and number of stirrups that I have rounded up, okay, to 9 times spacing, which we could call it the spacing that we have decided on, which was s naught. So you could say this is s naught, 325 over 2 is half of it. Okay, so we have number of stirrups times the spacing should not exceed this distance, the total distance, which is half of the beam equal to 4 meter. And the 4 meter deducted from the 4 meter, this spacing, this distance. Okay? This distance is deducted from the 4 meter. So it would be s naught over 2. S naught over 2. If it has not exceeded, then okay. Okay? Okay. In case if it has exceeded, what do you do? Exceed, what do you do? In case if it has exceeded the zone, you don't round it up to 9. You say, I keep it 8. I round it down to 8. So n would be equal to 8. So that it should not exceed, so that it wouldn't exceed this zone. Okay? That's the only thing that I wanted to highlight. If you have a question, you could ask. If not, sure, Bali.
مامۆستا لەو پرسیارە ئەگەر پێشانم دێ بزانە VU ئادی گەورەترە لە VC ئەنجامەکەی ئەگەر زیێت نەبی پێشانم دێ
هینی ئەم پرسیارێکدا VU ئادی ئەوەتە 274
ئەدی VC چەندە؟
VC
171 مامۆستا ئەگەر VN گەورەتر بێ لە VC کەواتە ئەمە پێویستمان بە سپیسینگە with design stirrups لەگەر spacing with ACI کۆد وەنی مامۆستا چونکە VN گەورەترە لە VC وەنیە؟
وایە تەواو
مامۆستا ئەدی ACI کۆدەکە ئێستا دەیکەین؟ بەس ئێستا بەس design stirrupسەکەمان کردیە
تەواو ئەخە چونکە دیزاینەکە چونکە فایەکەی تەنە هەر یەک هین ئەبێ هەتا ئەگاتە 5VC over 2 چونکە هەمووی فایتەنە ئەوە نییە بڵێ فایەکەی سیانزەیە ئەنجە دوایی لە مینیمەم زۆن بچم هینی کە بۆ بکەم فایتەنی بۆ بکەم تێگەی؟
ئەخ مامۆستا ئەزانم چۆنە مامۆستا لە دیستانسەکە برێ 2.98 کەمی برێ S over 2 ئەوە پێویستمان بە دیزانی ستیرابسە بەس لە 5VC over 2 بەو لاترەوە پێویستمان بە ACI کۆدا ینی
مەبەستت لە ڕووی سپیسینگ ئەم سپیسینگە پێویستمان 325 نییە پێویستمان بە 375 ئەوە مەبەستەوەە
بالضبط بەرێ
ئەوهاش ئەتوانی بیکە غەڵەت نییە هەردووکی غەڵەت نییە هەردووکی
دەبی نەمبەریشی لۆ بدۆزیەوە مادەم سپیسی
ئەبێ ئەویش نەمبەر بۆ بکەی وایە ڕاستێک غەڵەت نییە
بەس کردیتی لەو پرسیارە
بەڵێ
کردیتی لەو پرسیارە
نا ئەمە داوای نەکردووە من هەر لە خۆمە زیام کرد خۆم داوای نەکردووە ئەمە داوای کردووە determine required spacing هاي spacing
تو
okay that's a
أو
good
لو
point.
برسالة ببي
That's a good
شرحياتي
point.
درتي
من
رابردو
I didn't highlight
أفرتقي
that zone as a different zone because our phi, just simply because our phi is the minimum amount of shear reinforcement. So I could continue with the same spacing. I could continue with the same spacing. But nothing wrong if you could change the spacing and calculate new number of stirrups. It wouldn't change that much because the spacing is not too different. The spacing 375 and 325, you wouldn't save that much of shear reinforcement. يعني شت هيا بابلين اگر اما ديستانسكي زور بوايا فرقكي يعني 5 في سي لقل 5 في سي اوفر 2 زونكي زل بوايا وبيجي لوش اگر فايا كمان مثلا سيانزا بوايا او بو ديزاين